Alright, so let's solve this example. Now let's write the system of equations first. So this is x prime. The coefficient matrix is -2, -3, 3, -2x. First thing we want to do is we want to find the eigenvalues. So let's find the A minus lambda I matrix. So A minus lambda I will be -2 minus lambda minus 3, 3, -2 minus lambda, right? So this is A minus lambda. Now we want to find the determinant of this matrix and make it equal to 0 to find eigenvalues. So the determinant will be, first we multiply these two, so -2 minus lambda times -2 minus lambda is this is squared, minus 3 times 3 is -9, right? Equal to 0. So this is negative plus. So we have this quadratic equation. Now if I simplify this, if I expand this term and add 9 to it, so you should do that computation by yourself, we will get lambda square plus 4 lambda plus 30. Okay, now I'm going to use the quadratic equation. Okay, but again try to pause the video, use the quadratic equation by yourself. Okay, well, to save time, let me give you the eigenvalues directly. So the two eigenvalues are -2 plus or minus 3i. This is what you get if you use the quadratic equation. Okay, all right, so let's work with only a one eigenvalue, which will be -2 plus 3i. Okay, so we will work with these eigenvalues since this is complex. Okay, right, so now we need to find the eigenvector. So to find the eigenvector, we have to solve the equation A minus lambda I times k is equal to 0. So A is really -2, -3, 3, -2 minus, now lambda is this complex number, lambda times I is -2 plus 3i, 0, 0, -2 plus 3i, right? So this is lambda times I, the complex number times I. So this is I'm trying to find, just trying to find A minus lambda I matrix. Okay, still we are not dealing with this k. Okay, all right, so let's subtract these two. So use the brackets when you're subtracting. So here -3 minus 0 is -3, here 3, -2 minus -2 plus 3i. All right, so what we get from here is, when we expand the brackets, we get -2 plus 2 minus 3i, right? So -2 plus 2 cancel out, so I get minus 3i here, minus 3, 3 here, also we get minus 3i. Okay, so this is A minus lambda I matrix. All right, now we want to solve this equation for k. So we need to find little k1 and little k2, and the right hand side is 0, right? So what are the two equations we get? Let's find out. So if you multiply, we get -3i k1 minus 3k2 is equal to 0. 3k1 minus 3i k2 is equal to 0. So now from here we can say, well, we have two equations and we know these two equations are the same two equations. Okay, so what is the most simple equation? Well, let's use the second equation. Really, you can use any equation. Okay, so if we take this term to the right hand side, so we get 3i k2, 3 cancel out, so what we get is k1 is equal to I k2. This is the relationship. So let's choose a simple number for k2, which will be 1, then k1 will be I. So this is the eigenvector k1, and the eigenvalue we are working with is, if I remember correctly, -2 plus 3i. Okay, so we have everything we need. So let's decompose the eigenvector and write the real and imaginary part. So the real part of this will be 0, 1 plus I times the imaginary plus will be 1, 0. So B1 is here, B2 is here, right? And we know alpha and beta as well. All right, so now we are done with the problem. We just need to write down the solutions. So if you remember the formulas, okay, now we are going to use the formulas. The formulas to write the solutions are, x1 is B1 cosine beta t minus B2 sine beta t times e to the alpha t. x2 is p2 cosine beta t plus p1 sine beta t e to the alpha t. All right, so let's write down x1. Let's figure out what is x1. So we are going to use b1. So first b1 is 0, 1 times beta is 3, right? So cosine 3t minus b2 is 1, 0. I is not included in b2, okay? So sine 3t times e to the alpha is negative 2. So negative 2t. And then the x2 will be b2. b2 is 1, 0 cosine 3t plus b1 is 0, 1 sine 3t e to the negative 2t. So now let's simplify x1 furthermore, okay? So here this vector can be written as 0 cosine 3t, okay, minus this vector can be written as sine 3t and here 0. And then you multiply the whole thing by e to the negative 2t. Now you subtract these two vectors. So what we get is one vector. 0 minus sine 3t is minus sine 3t. And cosine 3t minus 0 is cosine 3t times e to the negative 2t. So that's x1. x2 is really, so here from here we get cosine 3t, okay, cosine 3t plus 0 times sine 3t is 0. 0 times cosine 3t is 0 from here, plus 1 sine 3t is sine 3t here. So this is this, e to the negative 2t. Okay, so these are the x1 and x2 vectors. Now we can write the general solution. C1 negative sine 3t cosine 3t e to the negative 2t plus C2 cosine 3t sine 3t e to the negative 2t. So this is the general solution. Okay, all right then. Yeah, thank you very much for watching this video.